Okay, let's talk about wind and water current problems. We talked about in class how anything that's in water is going to be considered a boat, anything in the air is going to be considered a plane. So when we're talking about a boat's rate, we're going to use the letter B. When we're going to talk about the current's rate, we're going to use the letter C. When we go upstream, we're going to be, or against the current, we're going to be B minus C for a rate, and the rate downstream, or with the current, would be B plus C. For the plane, its rate in still air is P. For the wind's rate, it is W. Rate with the wind, or a tailwind, is P plus W, and the rate against the wind, or with a headwind, would be P minus W. So let's see how we're going to do today. Oops. So our first problem says a man who spent one hour going 8 kilometers downstream in a motorboat needed 2 hours for the return trip upstream. Find the rate of the boat in still water, so just the B, and the rate of the current. Actually, I think it takes longer to write these problems than it does to solve them. So we're going to use a chart. And the reason why we're using a chart, because this is a motion problem, and the motion problems use the formula D equals RT. However, when we write our charts, we're going to write the formula RT equals D. Rate times time equals distance. So the two directions were downstream and upstream. We have rate, we have time, we have distance. And based off the idea of downstream, we're going to go faster, so boat plus current. Upstream, we're going to go slower, boat minus current. Now it says the man spent 1 hour going 8 kilometers, so that's the distance number. One goes downstream. Needed 2 hours to go upstream on the return trip. Return trip means he went the same distance. Now, in your chart, remembering that rate times time equals distance, right there you have your two equations. There's equation 1. 1 times the quantity B plus C equals 8. And here's the second one. 2 times the quantity B minus C equals 8. Alright, so one of the highlights to look for in this kind of problem is we have two choices. We can either distribute and then try to figure out what I need to multiply one or both equations by to get a match, or look for this little trick. If you notice on the second equation, the coefficient 2 goes evenly into 8. So here's what my two equations look like. I still have, when I distribute, B plus C equals 8, and now when I divide by -2, I have B minus C equals 4. So I'm ready to solve my system by simply adding and eliminating. So I get 2B equals 12, divide by 2, and I get B equals 6. So we write boat equals, now remember, this is representing the rate, so I need a rate label, which is distance over time. So we have kilometers per hour. Now here's the hard part that people want to fuss with, because they think it requires more work, but it's best to plug these equations, these values back into original equations so that you can try to catch your mistake. So we're going to substitute in 6 for B, and then solve it. So we have 6 plus c equals 8, subtract 6 from both sides, and we get c equals 2. So we would write the answer as current equals 2 kilometers per hour. So make sure you do not put variables in the answer here. You write out the words. Now I can double check it. If I subtract those two numbers, so I'm going to use this formula, the second one, this equation. If I subtract 6 and 2, multiply that answer by 2, does it give me 8? And I get 2 times 4 is 8, and sure enough I get 8 equals 8. So that says these answers are good. Alright, let's try another one. I think we kind of rotate between boats and planes. So number 2, we have with a tailwind, a plane flew 2,400 kilometers, so there's a distance label, in 4 hours, there's a time label, but it required 6 hours for the return trip against the wind. Find the rate of the plane, in still air, so just P, and the rate of the wind, W. So again, if you're all using the same variables we talked about in class, then you don't have to define anything. So we have two options how we write. We can either say tailwind, headwind, we can say with wind, against wind, whatever works for you. So I'm going to take the words I see, tailwind, and then against the wind. Top is always the same in these problems, rate, time, distance. Now I already know how to fill in a tailwind is with the wind, so that's P plus W, against the wind is P minus W. So with a tailwind, the plane flew 2,400 kilometers in 4 hours. But it required 6 hours for the return trip, which means the same distance, against the wind. So now again, I have my two equations. I have 4 times the quantity P plus W equals 2,400. And 6 times the quantity P minus W equals 2,400. So I'm going to try that trick again. If you notice, on the left side, I can divide both sides by 4. On the right side, I can divide both sides by 6. So my two equations become P plus W equals 600 and P minus W equals 400. So now I'm ready to solve my system by elimination when I add the two equations together. So I get 2P, the W's eliminate, equals 1,000, divide by 2, and I get P equals 500. So for my answer, right now, it's plane equals 500, and we have kilometers per hour. Now I'm going to plug that answer back into either original to solve for the wind. So 4 times the quantity 500 plus W equals 2,400. And I'm going to distribute on these instead of dividing by 4, just to give a different way to show you how to solve these. I'm going to subtract 2,000 from both sides, and I get 4W equals 400. Dividing by 4, I get W as 100. W represents wind, and we have the wind is 100 kilometers per hour. So what I'm going to do is I'm going to, I've already obviously tested in the green equation, so I'm going to take this information and test it in the blue equation. And that would give me 6 times the quantity, 500 minus 100. Does that equal 2400? So I get 6 times 400, and 6 times 4 is 24 and 2 extra zeros, and I get 2400 equals 2400. So that verifies, yep, that answer works. Okay. Let's try another one. It took Lisa 45 minutes to go 6 kilometers down a river in a boat and it took her 1.5 hours to return upstream. What was the speed of her boat? In still water, and the speed of the current. Okay, so the first one doesn't say the words downstream, but it says down a river, so that's your downstream. And then we have upstream for the return trip. It does mention that. And we have the same titles, rate, time, distance. Downstream, we're going to be, it's a boat, so we're going to be sped up by adding the current speed. And upstream, we're going to slow down. Now, where we run into an issue is this notion of 45 minutes. If you notice, the other time is in hours, and that's traditionally what we're going to be doing when we're talking about rate of bigger things. So what we need to do is figure out what part of an hour this is. So we get 1 hour is 60 minutes. So we have 45 over 60. And let's see, they both have, what, 15 in common? Divide by 15, we get a 3. Divide by 15, we get a 4. So what I'm going to write in the time is 3/4 for the downstream. Okay, got to have matching labels or it won't work. The distance traveled was 6 kilometers. Now in the other one it says 1.5 hours. Now I'm going to rewrite that as an improper fraction because it's going to make my solving easier. And because it's a return trip, we still have 6 kilometers. So here's my first equation. 3/4 times the quantity b plus c equals 6. And here's my second equation. 3/2 times the quantity b minus c equals 6. Now on these, to clear out the fractions, we're going to multiply both sides by the reciprocal. So I'm going to multiply by 4/3, and this one 2/3. So this goes, and then 3 goes into 6 twice. This goes, and 3 goes into 6 twice. First equation is b plus c equals 2 times 4 is 8. Second equation, b minus c is equal to 2 times 2 is 4. And now I'm ready to eliminate when I add my equations together. I get 2b, c's eliminate, equals 12. Divide by 2, b equals 6. So I get the boat is equal to 6, and then labels our kilometers per hour for rate. And then I'm going to plug this back into either original equation. It doesn't really matter which. I'll plug it in here. And I get 3/4 times 6 plus c equals 6. Now this time if I distributed, I would end up getting a fraction in 2 spots. So I'm actually going to go ahead and multiply by the reciprocal and not deal with that. So I get 6 plus c equals 8. Subtract 6 from both sides, and I get c equals 2. So the current is 2 kilometers per hour. Now I am going to test that going into that other equation. And I want to know if 3/2 times b minus c, so 6 take away 2, does that actually equal 6? So 3/2 times 4, 2 goes into 4 twice, 3 times 2 is 6. 6 equals 6, so that verifies that the answer is correct. Alright, we've got another one. The fourth problem. Donna can paddle her canoe in still water at 5 kilometers per hour. And what you should notice is that is a rate label. She is canoeing on a river that is flowing at 3 kilometers per hour. There's another rate label. Normally, that's what we're solving for. How far upstream can she travel if she must return to her starting point in 3 hours? Okay, so vastly different from the other problems, vastly different. And then we're going to actually use some strategies that we've used in Chapter 3 and also in Chapter 5. So we've got upstream, downstream. Rate times distance. Now, normally this is what we write. Upstream would be b minus c. But in this problem, they told us b was 5 and c was 3. So the boat in Stillwater, canoe in this case, was going at a rate of 5 kilometers per hour, and the canoe is on a river that is flowing, so current, at 3 kilometers per hour. Now, on the other guy, downstream would be b plus c. And we're going to write 5 plus 3. Okay? Now comes the weird part. How do we come up with the time? Well, we've got the two distances or the time together is 3 hours. So what we talked about in past chapters is if we have time that is representing two different portions, we're going to let one be x and the other one be the total time 3 minus x. So the question talks about how far upstream can she travel. So if we figure how far or how long it takes her to go upstream, then I can use that to plug into the formula to figure out how far upstream she can travel. So downstream would be 3 minus x. Now on this one, they didn't tell us the distance because that's what we're trying to solve for. And so what we're going to do is to figure out the distance by doing 5 take away 3 for upstream, which is 2, times the time, which is x. And then in the bottom one, we've got 5 plus 3 is 8 times the quantity 3 minus x. And because we're on a return trip, that means the distance upstream is going to equal the distance downstream. So we're going to take these two guys and set them equal to each other. So this is kind of back to chapter 5. We did this. So 2x equals 8 times the quantity 3 minus x. So we distribute, getting 24 minus 8x. We add 8x to both sides. We get 10x equals 24. Divide by 10. They both have a 2 in common. So that gives me 12 over 5. And then I'm going to divide let's see, did I do that right? Yeah. So what I end up with is 5 goes into 12 twice, which is 10, and there's 2/5 left over. So again, how far upstream can she travel if she must return to her starting point in 3 hours? So this value here doesn't represent distance. This value represents